Welcome to the class. Last class we have discussed about the principal stress and strain, and then we have discussed how to calculate the principal stress on an oblique plane using the analytical method. So we have derived the equations how to find out the principal stress in an oblique plane, and we have solved a couple of problems as well. So in this lecture today we will discuss more about the mode circle. So what is mode circle? So mode circle is nothing but a graphical method to find out the stresses and principal stresses, strains in any plane or basically in an oblique plane. So last class method was analytical one, we have derived from the basic equations, but today's mode circle method, it is very old method. This method using graphical drawing, so we can determine the principal stresses and strain in an oblique plane. So mode circle will be something like obviously something circle it will be. So this is basically the mode circle diagram. So for example, here you can see right side. This is a body, maybe a cross section of a body we are discussing. So cross section of a body, and then so this. I'll just 1 second. Yeah, so this is cross section of a body. So body is under different types of loads. So sigma y is basically principal stress or the normal stress we discussed in the before class. Normal stress is basically which is acting perpendicular to the body, so that is actually normal stress. And then we have the shear stress. So tau is basically the shear stress which will be acting on a plane. So all these things we have discussed. So mode circle is basically the graphical method to find out normal and the tangential stress and also the resultant stress in an oblique plane. So in the next slide we'll see how to calculate exactly in the mode circle. So this is a derivation when a body is subjected to two mutually perpendicular principal stress, then how to calculate the mode circle and how to draw. So basically mode circle is used to find out the stresses, normal stress, shear stress, and the resultant stress or resultant force in a particular section. So let's assume something here. So we have sigma 1 is obviously our major tensile stress, sigma 2 is the minor tensile stress, and theta is the angle made by the oblique plane. So you can imagine a body, maybe we just draw a body. So maybe this is a simple body where this is a tensile force is acting, right? So this is maybe your sigma 1, and this is also tensile, so two planes, so this is also sigma 2. And then so see there is no shear stress, so because in this derivation, so there may be the many cases. So in this case basically we are more focused on mm, two mutually perpendicular principles tensile stress. So these are the two mutually perpendicular tensile stresses acting on this body. So now we have to calculate, and the angle, this angle theta is made. So this angle they mentioned it is theta. So this is angle. So we have to find out in this plane what is the stress, normal stress as well as the shear stress, how to calculate. So that is the problem for this slide today. So how to draw the mode circle. So sigma 1 is the major tensile stress. That means this sigma 1 is actually greater than the sigma 2 because this is unequal. So sigma 2 is actually less than the sigma 1. So sigma 1 is actually measure, means more value will be there in the sigma 1. So sigma 2 is less and theta is the angle. So this theta I am talking. So if you can consider a body here and this rectangular body, maybe this is a rectangular body, but the two forces, two principal tensile forces are acting, sigma 1 downwards and sigma 2 horizontally. So now you are asked to find out uh, so some plane will be there, that is which is inclined plane. So this is an inclined plane, and this plane is making angle theta to the horizontal. So that is our main problem. So you have to find it out what is this value. So the tensile force in that plane and the normal force also, both we have to calculate. So using graphical method, mode cycle. Now we'll see how to draw the mode cycle. So this is our problem statement. So now let's see how to draw the mode cycle. So sigma 1 is greater than the sigma 2. So what we have to do, first you assume a point A. So just assume point A at this point, and then we draw our sigma 1. So sigma 1 is our major trace. So sigma 1 is very long. So from A we draw up to a certain line. So we have to assume some scale. For example, if you assume sigma 1, maybe sigma 1 is longer, right? Sigma 1 is greater than the sigma 2. So sigma 1 is very long. So maybe 10 centimeter line you can draw. So A to B is basically your sigma 1. And then you have the minor stress. So this axis is you have the minor stress sigma 2. So sigma 2 means maybe it is obviously lesser than sigma 1, so maybe it is a 5. So we have to consider some scale. So if sigma 1 is 10 centimeter, then sigma 2 is 5 centimeter because it is smaller, or maybe 7 centimeter, whatever may be the scale, small scale you have to assume. So sigma 2 is this, A to C is the sigma 2. So these two axes now we have, I mean in one axis we have just demarcated sigma 1 and sigma 2. And then from C we have to draw a circle. So C to B is basically the sigma 2, sigma 1 minus sigma 2. So this location. So AB is your entire sigma 1. Just let me write here. So sigma 1 equal to basically your A to B, and sigma 2 is basically A to C. Then what is this portion? C to B? C to B will be sigma 1 minus sigma 2. So I am talking about that C to B area. So this portion I am talking, C to B is sigma 2 minus sigma 1. So this C to B, the middle portion of C to B is intersects at O. So O is basically the half of C to B. And then O as the center, we draw a circle. So this circle center is O. So this circle actually we call it is a mode circle. So from O we draw. So what is the diameter of this circle? Diameter of this circle is C to B. C to B, which is nothing but sigma 1 minus sigma 2. Then what is the radius? Radius of the circle CO will be sigma 2, sigma 1 minus sigma 2 by 2. So half of total will be the radius. So we draw a circle. Now next is we have to then this angle, inclined angle is given theta. So what we'll do is, so from the center we take double of whatever angle is there. If it is theta, then we'll take 2 theta, so double angle, and we draw a line. Whatever angle will be given, if it is 30 degree in the problem it is given, inclined plane angle is 30 degree, then here 2 theta will be now 60 degree. So you have to draw a 60-degree line from this point, and this line will intersect the circle into E point. So this point is E point. So now draw the perpendicular to this line, so you will get D point now. So this is perpendicular. Now E to you connect C also, and E to A. So that's how one mode circle is drawn. Entire mode circle is drawn. So this is the entire procedure to draw the mode circle. So now as per the mode circle, resultant, so the normal stress in a oblique plane, so this is oblique plane. Basically our main objective is to find out what is the normal stress in this plane, oblique plane. Normal stress means this normal one, and shear stress also will calculate. Shear stress will be which is along the plane. So so after you draw this diagram, so A to D, so this length, entire length will be nothing but the normal force. So always in the mode circle, horizontal axis is a stress, normal stress axis, and the vertical axis is basically your shear stress or the tangential stress, vertical axis. So at this E point, so what will be the normal stress at this inclined plane, which is angular theta, will be equal to whatever is the length from A to D. D means up to E point, whatever is the horizontal distance. So A to D will be your normal stress on an oblique plane, length of A to D. Similarly for E to D, so this vertical angle, vertical line, so that's what we discussed. No, the horizontal line will be the normal stress, and vertical line will be your shear stress or the tangential stress. So ED will be this much. So length of ED will be nothing but your shear force at this plane, and length of A to E will be your resultant stress on a oblique plane. So in this plane, so this is a normal stress, and shear stress is acting along the line. So two force, if you draw a resultant will be in this inclined direction. So that force will be this much, A to E, length of this. So that's how from we draw a mode circle, and easily we can compute whatever is the stress strain and normal stress, shear stress, and the resultant stress in a any oblique plane. So it may be theta, may be any degree. So using this diagram, you can easily compute what is the normal stress and shear stress on a particular plane. So radius of the mode circle is already we discussed. So this is a mode circle. So radius will be half of this CB. So CB is sigma 1 minus sigma 2, half is by 2, and this angle phi, so phi is basically this part, this angle. So phi is, we call it angle of obliquity. So that's how the so now let's calculate what is the value of AD. So AD, we already discussed, AD will be the normal stress in that oblique plane. So how to calculate the value of AD? So this is our first derivation. So CO is which was CO is this portion, that is radius of the mode circle, equal to OB. OB means O to B, obviously radius of the mode circle, and OE. So all are radius. So radius of the mode circle already we have compute sigma 1 minus sigma 2 by 2. That is the radius of mode circle. Now what is AO? AO will be AC plus CO. AO equal to AC plus CO. So what is AC? AC is nothing but sigma 2. And what is CO? CO is the radius of the mode circle. That is sigma 1 minus sigma 2 by 2. This portion. So AO equal to sigma 2 is this portion. AC is sigma 2 plus the radius of the mode circle. Now if you just add it, you will get sigma 1 plus sigma 2 by 2 is AO. A to O. So our intention is to find out what is the length A to D. So A to D will give you the normal stress in a oblique plane. So AO we have computed. Now we have to compute OD. Then we can find it out what is AD entirely. So OD will be how much? So OD, so this radius you know. Radius is sigma 1 minus sigma 2 by 2. OE. OE you know, and this angle also you know, 2 theta. So easily you can compute what is the value of OD. So OD will be nothing but this line into cos 2 theta. So OV will be OE is this part into cos 2 theta. Simple triangular trigonometry will get it this. So now OE is basically what? That radius of the circle. Just substitute the value sigma 1 minus sigma 2 by 2 and cos 2 theta. So you got now OD. So now what is then AD entire length? AD will be AO, A to O plus O to D. So AO we computed sigma 1 plus sigma 2 by 2 plus OD. OD will be this one. Just now we computed sigma 1 minus sigma 2 by cos 2 theta. So this is basically the normal stress in that oblique plane. In the last class we have shown that oblique plane theta, this is the normal stress AD. Now what is ED? So ED will be simply O is sine component. So O is cos component was OD and sine component is ED. So ED will be O is sine component. So O is just substitute the value, we will get the tangential stress. So now we computed both the things. So now you can easily compute what is AE. Already we know this AD and we know ED. Just simply root over AD square plus OE square, you will get it the length of AE. So that's how actually using mode circle easily we can compute what is the normal stress and the shear stress in a any oblique plane. So from this what we can interfere. So this is a mode circle, just now same example. So the normal stress along the line ACB. So this is normal stress is always along the line ACB. So when will be the normal stress maximum? So normal stress will be maximum when theta equal to 0. So if you remember the length of AD was the normal stress, right? So when AD will be maximum? So when AD equal to AB is maximum. When AD equal to AB entire line, then only you will get the normal stress, maximum normal stress in a particular plane. then what will be the angle of that plane? So when AD equal to AB, so you will have the maximum normal stress. So when AD will be becomes, so when the 2 theta, so when 2 theta equal to 0 degree, so when this line will is just simply horizontal, so when 2 theta equal to 0 degree, then you will get OD equal to, I mean the AD equal to AB. Then what is the value of theta from here you will get? So theta value you will get is 0 degree. So when you have when the forces, when you take the inclined force parallel to the section, then you will get maximum normal stress. Now what the and the shear stress we computed, so this is the value of shear stress. So shear stress will be, last slide we have calculated, no? Sigma t equal to sigma 1 minus sigma 2 by 2 into sine 2 theta. So when sigma t will be maximum? So when sine 2 theta, sine 2 theta equal to, so when sine 2 theta equal to, you will get 1 maximum. Then only this sigma t will be maximum. So when 2 theta equal to 1, sine 2 theta. So sine 90 is basically 1. So you can just 1, you replace it to sine 90. So basically 2 theta equal to 90 degree and theta equal to 45 degree. So when you have theta equal to 45 degree, that if a body, so this is a body you can imagine, and two forces are acting, P1, maybe P is acting only one direction. So if you take a plane exactly parallel to this section, first force, so in this plane, or that share that so if you consider this plane, so in this plane you will get maximum normal stress, and if you take a plane 45-degree angle with this, so this angle is, if it is 45 degree, if you consider, so in this plane you will get the maximum shear stress. So this 0 degree is not this plane, actually this from this is, if you draw a plane, this one is 0 degree. So in this plane you will get the maximum normal stress, and this 45-degree inclined plane you will get the maximum shear stress. So that's what we can calculate and refer from the simple mode circle. So now let's solve a problem quickly regarding the mode circle. So what is the example here? The tensile stress at any point across the two mutually perpendicular plane. So you can consider two mutually perpendicular planes. So this is one plane, this is another plane. So two mutually perpendicular plane, and one plane has 120 Newton per mm square. So force, so tensile strength. So tensile stress, so sigma 1 is given is 120, and another perpendicular plane, this plane, tensile force is given as 60. So sigma 1 and sigma 2 is given to you. So what determines the normal and tangential stress and the resultant stress on a plane inclined 30 degrees from the minor axis. So which one is minor axis? Minor axis is lesser value. So from this angle you draw a plane which angle is 30 degree, and in this plane you have to find it out what is the value of normal stress sigma n, and what is the value of shear stress sigma t. So sigma and sigma t you have to find it out, and also the resultant force of sigma, this and so this also, sigma n and sigma t, resultant force will be inclined, so that is, so these three value you have to compute. So sigma 1 is given to us 120, sigma 2 is also given 60 in the question. So both, so angle, this angle also given 30 degree. So now as I mentioned, we have to assume some scale. So 1 centimeter is equal to, because you have to draw the mode circle, so that's why you have to assume some scale. So 1 centimeter is equal to 10 Newton per mm square. Some scale we have assumed. You can assume your any scale. Then what will be the length of sigma 1? So first we have to draw a line of sigma 1. So what will be the length? So we considered 1 centimeter is equal to 10 Newton per mm square. So sigma 1 is given 120. So total length will be simply 120 by 12 centimeters. So from A, first we have to draw a line up to B will be 12 centimeters. So 12 centimeter from scale, you just draw a line AB. Next is sigma 2. So sigma 2 you have to draw here. Sigma 2's value is given 60 and our scale is 10. So 60 by 10 you will get 6 centimeters. So from here again you have to draw 6 centimeter point C, you will get it. So this is sigma 1 is entire length, which is nothing but 12 centimeter, and the half is basically sigma 1 is 6 centimeter AC. So for this is the mode circle now. So how to draw next? C to B, we take middle point O. From O we have to draw a circle. So that is our mode circle. Very simple. And then you connect from E. So OE you have to draw if the angle, this angle is given 30 degrees or whatever with the theta. So 2 theta you have to consider, and you have to draw a line. So that line intersects at E, and then draw a perpendicular. You will get D and just connect all the lines. So this is mode circle over. So now what is the value of A to B is given already you computed, that is 12 centimeter. Now you have to compute simple formula. Last class we have discussed, last slide, AD. So AD will be, already we have computed the formula. So AD will be AO plus OD. So what is A? So that's what. So just find out what is AD then. AD will be AO plus OD. So use the formula last slide we have derived everything. So you will get AD value is this one, ED value is perpendicular. So this is the normal stress in the oblique plane. This is the shear stress ED, but just use substitute the formula we have derived in the last slide. And AE is this one, horizontal one. So the normal stress will be, so once you know the length, just multiply with the scale. So AD length is actually 10.5 centimeter. So our scale was 10, if you remember. 1 Newton per mm square you considered 10. Sorry, 1 centimeter equal to 10 Newton per mm square you considered. So this is we multiplied with 10. Then the centimeter will be converted into Newton per mm square. So all three you convert and you will get it the final value. So like that, actually we have to solve the mode circle equations. Is very easily we can find it out using this graphical diagram. We can compute the normal stress and shear stress. Thank you.